Welcome to Spring LIB.
So in this question, we have a precipitator. So this really is just a parallel, a cylindrical capacitor. So we have this potential difference between the inner cylinder and the outer cylinder. So and then there will be an electric field due to the potential difference. The question tells us that when the electric field reaches this particular value ES, which is 2.7 times 10 to the 6 Newton per coulomb, when the electric field reaches this magnitude, the air will be ionized. And this question, we have this capacitor and we know RA and RB, and we know that we want to find the amount of voltage such that in a cylindrical area with R equals 5 RB, the air will be dissociated. That is to say that R equals 5 RB is radius in which the electric field will reach 2.7 times 10 to the 6 Newton per coulomb. So we know that for a cylindrical capacitor, there are a couple of things we know. So firstly, we know that due to Gauss's law, we know the electric field for such system, E, equals 1 over 2 pi epsilon lambda over R. Actually, since R is where the air becomes ionized, I'll call this ES. So this is what we have for the electric field. And the second thing is in the second section of this chapter, we know the capacitor of a cylindrical capacitor. The capacitance of this cylindrical capacitor is this equation. This can be found in example 2 of this section. And once we know this, we know the capacitance, and we can find the voltage by V equals Q over C. So if we look at here, all we need is the Q, and Q equals lambda times L. So over 9 RA minus RB. So what we really need here is we need to know what lambda is, because the L will cancel. And we can find lambda from here, because this tells us lambda equals ES times R times this tells us lambda equals this. And because we know R equals 5 times RB, this can also be written as times and this lambda is Q over L. So we can plug this lambda into here, and this gives us this is just lambda divided by 2 pi epsilon times ln RA minus RB. So this, if we observe, we can see that the 2 pi epsilon term in the numerator and denominator will cancel each other. So we are left with zero RB ES ln RA divided by RB. So at this point, we can see that we get all the parameters we're looking for. So, and we can explicitly write all the numbers. .1 meter over 10 to the negative 4 Newton. This in total gives us a voltage of 9300 volt.